Okay, 18. This is chapter 7, lesson 6. This is trigonometry and modelling chapter, and today we're going to be solving some equations using compound or double angle formulae. If you haven't watched the other videos, you need to watch those first, otherwise this will make absolutely no sense whatsoever. Okay, let's get cracking. We've got 3 of sine A plus 30 equals 15 root 2 loss of cos A. Now neither of these are double angles. This is quite clearly a compound angle, okay, and this is pretty standard stuff. What we can do first off though is we can divide through by 3. Okay, watch out for the simplifications that you can do early. So I'll know that I've got sine of A plus 30 is equal to root 2 of cos A, where 0 up to A up to 360. So A is between 0 and 360 degrees. Okay, so we're going to be casting something at the end is a pretty good prediction. Okay, if you want to, you could graph some of these things on GeoGebra and see where they intersect on there, but obviously GeoGebra is radians, isn't it? So we have sine of A plus 30. Okay, well 30 is my B when I'm using these compound angle formulae. In the compound angle formulae, what I'll have is going to be sine of A cos of 30 plus cos of A sine of 30. Okay, now cos of 30 you can tap into your calculator, or you can use the magic triangles, or you can just use your memory, which is going to be root 3 over 2 of sine A plus sine of 30, which is 1/2 cos A. Okay, and that's the left hand side. Tied it up a bit, and that left hand side equals 5 root 2 cos A. Don't forget I divided through by 3 at the start. Okay, now what we're going to be trying to do is I'm going to try to get the cos's on the same side, okay, as each other, and so what I'm going to have is going to be root 3 over 2 sine A is going to equal 5 root 2 cos A subtract 1/2 cos A. Now I find it just that little bit strange that this doesn't have a denominator. I find that a little bit annoying. Okay, so we're going to tidy that up as well. We'll get root 3 over 2 sine A equals 10 root 2 over 2 minus 1 over 2 cos A. Okay, so there's two things that I've done there. I've multiplied through by 2 in the numerator and the denominator for this coefficient here, and I've also factored out the cos A. Okay, so this thing would have turned into 10 root 2 over 2 minus 1/2, and I've factored out the cos A. Okay, I am now going to have root 3 over 2 sine A is going to equal negative 1 plus 10 root 2 all over 2 lots of cos A. I'm going to cancel out these dividing things, okay, and from here what I'm going to have is root 3 sine A equals negative 1 plus 10 root 2 of cos A. Now it looks like we can't really do a lot with it, but you'll probably spot actually that I can produce a tan here. Okay, I'll never be able to solve this sort of stuff unless I have a singular trigonometric ratio, unless I have tan of something equals something, or cos of something equals something. I need a singular one, and neither of these are squared, so none of them are going to end up kind of making that year 1 rule of sine squared plus cos squared equals 1. None of that's going to happen. What I can actually do is I can move this under. I can divide both sides by cos of A, and I can divide both sides by root 3. Essentially I'm dividing both sides by root 3 cos A, but what I'll end up with is going to be sine of A over cos of A will equal negative 1 plus 10 root 2 over root 3, which means that tan of A equals that stuff. Okay, and what that means also is that A equals arctan, tan to the negative 1, of, we would have negative 1 plus 10 root 2 over root 3. So we'll try to find out what that thing is. So we have tan to the negative 1, open up a fraction, you'll get negative 1 plus 10 root 2 over root 3. Type it into your calculator, making sure that you're in degrees, obviously, and you're going to get that A is equal to 82.49 degrees. Great, but it's not done. Okay, there's more to go here. We need to cast it. Okay, 82.49 is there. 82.49. Okay, tan was working out to be like a positive, so we need to end up in this region here. Tan's positive here, and so we need the other region where tan's positive, which is going to be there, 82.49. And 180 plus 82.49 is going to be 200, pardon me, and 62.49. So A equals 82.49 degrees and 262.49 degrees. Okay, all done. Pretty weird, but not too scary. It's just involving lots and lots and lots of your trig skills from year one that you might need to go back and have a look at. So, moving on. Next, we have 2 cos of 2x plus sine of x plus 1 equals 0. Now, this looks faintly like a quadratic to me. Okay, it looks a bit like it, but obviously there's a problem because I've got cos and I've got sine. Again, you won't be able to solve anything like this until you've got a singular cos or a singular sine or a singular tan and no other trigonometric ratio involved in it. So what I'm going to do is I'm going to take a look at cos of 2x and I'm going to change that cos of 2x into whichever one of these suits me most. Now look here, I've got sine of x. I want everything to be as much sine of x as I can possibly get, because that way I'm not going to have mixtures of different trigonometric ratios. So I'll have 2 lots of 1 subtract 2 sine squared x plus sine of x plus 1 equals 0. Okay, expand this out and we'll end up with 2 minus 4 sine squared x plus sine of x plus 1 equals 0, and we can collect the like terms. We can end up with 4 sine squared x plus sine of x plus 3 equals 0. Now it's just my personal preference, but I'm going to multiply through by -1. Okay, so I'll get 4 sine squared x minus sine of x minus 3 equals 0. I just really like this lead coefficient to be positive. No major reason why, I just think it just makes things a little bit easier. Now this here is a quadratic. You could, if you want to, invent like a variable. You could say that a equals sine of x, and so you could have 4a squared minus a minus 3, and then replace that later. For me though, I think it's, if you're in year 13, you should really be pretty comfortable just dealing with sine written in there. So we are going to multiply to get -12, which is 4 times -3, by the way, and we are going to add to get -1. Now the numbers that will do that are going to be -4 and 3. So we're going to get 4 sine squared x minus 4 sine x plus 3 sine x minus 3 equals 0. Factorise each side and we'll end up with 4 sine of x, lots of sine of x minus 1 plus 3, lots of sine of x plus minus, pardon me, 1 equals 0, and your factorised version will be 4 sine x plus 3 and sine of x minus 1 equals 0. Now, 2 values can only ever equal 0 if they both, when they multiply together, if they're both 0, 0 times 0 is obviously 0, or if one of them is 0, at least one of them has to be 0 in order for us to be able to solve it. So we're going to solve each of these brackets. We're going to get case 1. Now case 1 is going to be this one here. Okay, so 4 sine of x plus 3 equals 0. Sine of x is equal to -3 quarters. Okay, which means that x is equal to sine to the -1, arc sine, of -3 quarters. Now, sine to the -1 of -3 quarters actually comes out as -48.59. Okay, but that obviously is not a legitimate solution for us because, for one, it's outside of our domain for x, okay, and also we haven't casted anything just yet. Now, let's take a look. -48.59 would be in that quadrant there. We'd expect it to be in the negative for sine, okay, so we're going to need to find other positions where sine is negative, okay. So we'll cast with sine being negative, so it'll be there as well, because sine's positive here and positive here. So we'll have 0, 90, 180, 180 plus 48.59, which means that x will equal 228.59, as well as x being equal to 360 subtract 48.59. 360 subtract 48.59 is 311.41. Okay, 311.41 degrees and degrees. Now that's only one case considered. There's another case to consider as well. Okay, I'm going to make a bit of a fuss of those because I don't want to lose them. The other case, case 2, occurs when sine of x minus 1 equals 0, which happens when sine of x equals 1. Okay, now the sine wave looks like this. Okay, when does it equal 1? Well, that happens at 90 degrees. Okay, so your values for x are 90 degrees, 228 degrees, 228, pardon me, 0.59 degrees, give you decimal places, and 311.41 degrees. Okay, job done. Quite an interesting one. Moving on. Your tasks for this lesson are in exercise 7D, which is on pages 180 to 181 of the Edexcel Year 2 book. This is the Active Teach book. I would like you to do questions 1A, 1C, 5A, 5C, 5E, 5G and 5I. And if you want a little bit of an extension, something different to do question 4. If you want to do any of the missing bits from questions 1 and 5, or if you want to do questions 2 and 3, you're more than welcome to. Don't go any further onto that exercise because that stuff will be covered in the next lesson. Okay, make sure that you've done the questions, you've marked them before you upload them to Google Classroom. Let me know if you've got any issues. Good luck.